First, we'll write planner for a week. Today is Saturday. Today's work, practice whatever done in class 2 times. Hello? Hello?
Yes, sir.
Law of motion I have done till what? MCQ of law of motion.
We have not started. We have started with work power energy.
Law of motion we have not yet started.
We did some MCQs of laws of motion. We did not complete it.
Acha. From the sheet we did some MCQs.
Yes, sir.
Okay, no problem. So practice whatever done in a class 2 times. Then on Monday, Sunday I have not given any work to you. Monday you have to practice all. See, today we'll complete work power energy up to maximum. So here all remaining MCQs of work power energy. Then from here I am just writing theory which you have to study. First, define force, comma inertia, comma impulse, force, inertia, impulse, momentum. Newton's first law, second law, third law, all simple definition. And on Wednesday, state and prove law of conservation of linear momentum. Law of conservation of linear momentum. Then collision, types of collision. Here coefficient of restitution. Coefficient of restitution and revise MCQs of explosion. This I have done, I think, and collision from MCQ sheet. Friday test on theory plus MCQ of law of motion. Only collision and explosion part. So this is your 1 week work. Saturday to Friday.
So what's for Thursday last?
Coefficient of restitution, revise MCQ of explosion and collision from the sheet.
Okay, sir. Thank you.
Can I clear this now? Yes, done.
Yes, sir.
Now we'll start with MCQ of first work power energy. Tell me, last class I completed till which sum?
44.
44 we completed. Okay. Now 45th onwards we are moving ahead.
Sir,
Yes.
we have to do 40th sum.
40th we have to do. Okay. 40th. Particle of mass m is accelerating with uniform velocity v when time is t1. Find work done in t. Work done in t we want if it is uniformly accelerating. Now because it is uniformly accelerating, so acceleration is constant throughout. So at least I can find first acceleration part. V is u plus at. So V is V, body starting from rest, A when time is t1. V is A time t1. So A will become V upon t1. Now work done is change in kinetic energy. This is half m final velocity square minus initial velocity square, which is half m. Final velocity means a square t square, because v is at, after time t we want. Initial is 0. So it will be half of m. A is v. V square upon t1 square into t square. This is the required answer. Half m v square, that is option A. Yes, completed now.
Yes, sir.
Yes, sir.
Next one, 45, theoretical question, important one. Displacement force graph is given as shown. This is x1, this is x2. The force acting on a body moving along x-axis. The force acting on a body moving along x-axis varies with the position of particle as shown. The body is in stable equilibrium at x1 or x2 or both or neither. What is meaning of body is at equilibrium? For equilibrium, F equal to 0. They want stable equilibrium. So on x-axis, can I say force is 0? On x-axis, y is 0. So here force is 0. Can I say like this? Hello?
Yes, sir.
Yes, sir.
Therefore, at x1, comma x2, we have equilibrium. But they are telling stable equilibrium is which one? This is three condition. If the body is here, that means minimum potential energy. It is in stable equilibrium. Because when you push it upward, it comes back to the original position. When it is at peak, then it will fall down when we push. So it will be unstable equilibrium. This is neutral equilibrium. Now, at x1, if we push the body on right hand side, what is nature of force, positive or negative? If I push on right hand side from x1, then force will be positive or negative?
Positive.
Positive. Positive means it will move body away, पीछे नहीं लाएगा. पीछे मतलब negative होना चाहिए. It will move body. हेलो, हाँ अभी आएगा. ठीक है, करता हूँ. It will move body away. So unstable equilibrium. At x equals to x2, if we push body away, now what is the force, positive or negative?
Negative.
Force is negative. Negative means it will bring body back. It will bring body back. Correct ना? Restoring बोलते हैं ना उसको. So can I say x2 is stable equilibrium? Therefore x
Yes, sir.
equals, yes, is stable equilibrium. That means we have two equilibrium, x1, x2, but x1 is unstable, x2 is stable equilibrium. So x2 is option B. Write down. Now write everything properly because theoretical MCQ. Once you takes time, next time onwards it is easy. Completed, huh?
What is written there? X is equal to x1 if we push the body.
If we push the body on right hand side, force will be positive. It will move body away, so unstable equilibrium. If we push the body on right hand side.
Second.
Can I clear now everything?
Yes, sir.
Yes, sir.
Yes, sir.
Next sum, number 46, also theoretical based. The given plot shows the variation of U, the potential energy of interaction between two particles with the distance separating them as r. So graph of U against distance separating the two particle r is as shown in the figure. Is as shown in the figure. So this is A, B, C, D, E, F. E, F. B and D are equilibrium point. We have to check which statements are correct. B and D are equilibrium point. Is it correct? B and D are equilibrium point. B and D are equilibrium points. Correct or incorrect? This is graph of F against distance or potential energy against distance. Hello?
Potential energy.
So at B and D, F is not 0, but U is 0. And if F 0, then it is equilibrium. So this is not equilibrium point. If du upon dr is 0, then equilibrium point. Because force is rate of du by dx is called force. How it is seen. Work done against force is stored energy. So du is minus f dx. So if du by dx is minus f and that is 0, then we can say it is equilibrium. Not if energy is 0, then it is equilibrium. So B and D is equilibrium is incorrect. C is point of stable equilibrium. Let us check. At C, if I draw line parallel to our axis, so we get at C, du by dr, that is slope is 0, f is 0, therefore it is equilibrium. Therefore it is equilibrium. Now stable or not, that we have to check. If I push the body to the right, see carefully. So slope at right or between C and D, slope is positive. F is minus du by dx. So F will be minus of plus. That means it is negative. Negative means restoring, and restoring means stable. So second is correct option. Stable equilibrium. Just copy first and second, then third, fourth I am explaining. Restoring means attractive force and positive means repulsive force. After completing tell, so that third and fourth point we can see. Right now we got second point is correct. Yes, done. First and second point.
Yes, sir.
Okay. See the third one now. Third, it is the force of interaction. The force of interaction between two particles is attractive between C and D and repulsive between D and D. Okay. Between C and D, it is attractive, and between D and E, it is repulsive. So force is attractive if negative. If F is negative, then attractive. We have to check now. If F is positive, then repulsive. In UV graph, F is minus du by dx or dr. Du by dx matlab slope. Between C and D, what will be slope if you draw line touching acute angle? Na? This is a curve. If I want slope, I have to draw tangent here. With x-axis, what angle it is making between C and D? Yes, between C and D.
Acute
Between C and D, angle made by tangent is acute. Therefore, slope du by dx is positive. So F is negative. Therefore, attractive between C and D. अब check करते हैं D and D. Also, between D and E, tangent makes acute angle, है ना? Between D and D also, if you draw, see, acute angle हो गया ना इधर हर जगह पे. Acute angle. Therefore, F is attractive. They are telling C and D is repulsive, and D and E is C and D is attractive, D and D repulsive. No, both are attractive. So C is not correct because of given option. Reasons write down properly. F negative means attractive, positive means repulsive. In our case, in both cases, it is attractive. Because both cases attractive, so third option is wrong. Fourth, let us check now. Fourth case. Fourth case, force of interaction is repulsive between E and F. Force is repulsive between E and F. Let us check between E and F. Between E and F, if I draw tangent to this curve, it will make obtuse angle. So between E and F, tangent to the curve makes obtuse angle. Therefore, slope is negative. Between E and F, slope is negative. So du by dr is negative. F is minus of du by dr, which is minus of minus, that is positive. Therefore, force is repulsive is correct option. So our answer will be 2 and 4 are correct. So 2 and 4 are correct is given in C. Now complete till end. Yes, completed.
Yes, sir. Yes, sir.
Okay. Now we'll do next sum 47th. Three particles A, B, C are projected from the top of tower with same speed. Projected with same speed from the top of tower. So initial velocity of A is same as B is same as C. A is thrown straight upward. A is thrown upward. B is thrown down and C is thrown horizontal. What will be their speed when it hits the ground with VA, VB, VC? So generally we feel VB will be greater, but actually all are same. The V square is U square plus 2S. Since UA, UB, UC are same. S means height. Also A is G is same for all particles. Now height covered by A when it is thrown upward and downward will be same as H only, net displacement, because up down either the cancel. So can I say H of A, H of B, H of C is also same? So V A is same as VB is same as VC. Option B. Again see, initial velocity सबका same, acceleration भी सबका same, height भी सबका same, तो ये final velocity भी same होगा ना? Hello?
Yes, sir.
See, conceptually followed. Now why it is same? Because it goes up by 10, comes down by 10, तो net ये 0. फिर इधर से इधर h, b का भी h, c भी ऐसा जाके नीचे आएगा h. So net height covered is same for both, all the three. Height same, a same, u same, v same. Now solve.
That's sir.
Okay. Forty-eighth one. A body of mass 0.1 kg. A body of mass 0.1 kg is moving with velocity of 10 meter per second, hits a spring fixed at other end of force constant 1000 Newton per meter, and comes to rest, compresses the spring, then compression of the spring will be how much? A body of mass this moving with velocity hits the spring, spring gets compressed, that compression will be how much? If this is suppose spring fixed on a support, a body hits the spring, compresses the spring and comes to rest. So I can say loss of kinetic energy of body will become gain in potential energy of the spring. Correct?
Yes, sir.
So half mv square is loss in kinetic and half kx square is gain in potential. This we have done for spring. Potential energy gained is half kx square. So half of cancel, v square equal to kx we want. mv square upon k in root will be x. So x is 10 raised to minus 1, v is 10 square, k is 10 raised to 3 in root. 10 raised to minus 1, x will be 10 raised to 1, this goes up. So 10 raised to minus 1 minus 2. X is 10 raised to minus 1. 0.1 meter will be the compression. 0.1 option is B. Have you followed concept first? A body is moving, hits the spring, spring gets compressed. So इसका energy इसको transfer हो जाएगा. So we have used law of conservation of energy. Solve.
Done, sir.
Next sum number 49. A mass of 2 kg falls from height of 40 centimeter. Falls from height of 40 centimeter. on a spring with spring constant, on a spring of spring constant 1960 Newton per meter. The spring is compressed by how much? So when it falls on the spring, spring will get compressed, suppose by distance x. G is 9.8. Okay. Now again I can say loss in, it is falling, gravitational potential energy is gain in stored elastic energy. So from here it comes, it will be mg h plus x. हाइट h से गिरा और इसको और भी x compress किया. So net this body is falling by this much amount, h plus x, and stored potential energy is half kx square. M is 2, g is 9.8, h is 40 centimeters, so 0.4 plus x we have to calculate, equals to half into 1960 into 1960 into x square. This is 2980. So 2980, 19.6.4 plus x equals to 980 x square. Now if you want with 98, you can cancel 98 into 10, 98 into 0.2 is 19.6. So this is 0.4 plus x 10 upon 0.2 x square. So we get 0.4 plus x equals to 100 upon 2x square. This is 50. So 50x square minus x minus 0.4 is 0. Hello? Till this follow?
Yes, sir.
Yes, sir.
Just copy till this, then I'm solving this quadratic equation. Solve.
Sir, there is some error.
Where?
I think so because there is no answer fitting in that equation.
You are looking wrong. Answer is in centimeter. We will get in meter.
It's 10 centimeter.
Yes, 10 centimeter will come. If you put 0.1, see, it will fit. Is it fitting? 0.1 square is 0.5 minus 0.5 minus 0.1 will become 0.4. 0.4 will become 0. Okay.
Sir,
So should I solve or you got the idea? उल्टा भी जा सकते हैं by putting the value. See, we got this much. Either I can start with this method, quadratic equation. Minus b plus or minus root of b square minus 4ac upon 2a. So this is minus 1 plus or minus root of minus 1 square minus 4 into 50 into minus 0.4 upon 2 into 50. So that will become minus 1 plus or minus root of 1 minus minus plus 4 into 0.4. 4.4 into 10 is 4, 16 upon 100. So 16 is close to 16 plus or minus 1 plus or minus 4 upon 3. So this will be a bit lengthy calculation, but if you do by shortcut method, minus b matlab ye minus ho gaya, minus minus plus 1 plus 1. So 1 plus 4 is 5. 5 upon 100 is 0.5. No, 2 into 50. चलो इधर 0.1 डाला तो हो जाएगा ना आंसर, समझ गए आपको ये? If we put x equal to 0.1, it will be balancing. Hello?
Yes, sir.
Yes, sir.
So do reverse, that is best. So put x equals to 0.1 meter, we get solution. Okay, so this is the answer. 0.1 means 10 centimeter, option A. Page 50, that was the September. एक मिनट सॉल्व करके बता देता हूँ. We will solve also, don't worry. So this is 1 plus or minus root of 1 minus minus plus 200 into 0.4. 200 into 0.4 is equals to, what is 200 into 0.4? 80 upon 100. So this is 1 plus or minus 81 upon 100. That means 1 plus 9 upon 100, because negative is not possible. So it is 10 upon 100 equals to 0.1 meter, that is 10 centimeter. Okay, exactly what. After this I am doing 50th. Please write till end properly. Yes, done. Can I rub it now?
Yes, sir.
58. A toy gun uses spring of large value of force constant K when charged before triggered in the upward direction. The spring is compressed by small distance x. If mass m is being triggered of mass m of short is m, on being triggered will go up to height of how much? Okay,
kx square upon 2 mg.
no, half kx is potential energy.
I told kx square upon 2 mg.
Acha, final answer you are telling?
Yes, sir.
Okay, so this will be nothing but mgh. So k x square upon 2 mg is height, correct. See, 51. A body is falling under gravity when it loses potential energy by u. Its speed becomes v. The mass of the body will be how much? Take 1 minute. I think you all will be able to answer this. A
U
body,
upon 2 mv square.
uh, no, it is, we want velocity.
2u upon
To
v
u
square.
upon v square.
Correct. So this is getting converted into potential. Loss in potential is gain in kinetic. So therefore we get mass equals to 2u upon v square. Correct option. 2u upon v square is correct. 52. Before I start 52, just see this small concept. This is suppose bottom. If body goes up to height h and makes angle theta with vertical. This is length of string. This is also length of string. Can you tell me what will be this distance in terms of L? L cos theta.
Yes.
So can I say H is L minus L cos theta? Therefore, H is L into 1 minus cos theta. Can we say like this?
Yes, sir.
Same way, if from the top, what is fixed here, suppose, it comes here downward by H. So this is L, this is L. Now what is H? If L makes angle theta with vertical.
Cos
Same height.
theta h is equals to L cos theta minus 1.
No, from here to here it is L, na? So it will become L minus L cos theta. So whether from top comes downward makes angle theta, or from bottom goes upward makes theta, H is same, L into 1 minus cos theta. Clear meaning?
Yes, sir.
Just draw this two diagram to understand. If body moves up by theta or comes down by theta, then height is L into 1 minus cos theta. Draw this diagram, then I am doing 52nd onwards. Done? Shall I start 52 now?
Yes, sir.
A bead can slide on a smooth circular wire frame of radius r. A bead can slide on a smooth circular wire frame of radius r which is fixed in vertical plane. The bead is displaced slightly from the highest point speed of the bead as function of angle theta made by the bead with the vertical line. Bead comes somewhere here, makes angle theta. Suppose it falls by h. We have to find what is velocity in terms of theta. So loss in potential energy will be gain in kinetic energy. Gain in kinetic energy is half mv square. Loss in potential is mgh. Now h is r into 1 minus cos theta. L into 1 minus cos theta, I wrote r because L is r, equal to half v square. So v is root of 2 times gr into 1 minus cos theta. Root 2 gr, 1 minus cos theta, option. Yes, understood? Huh? So weather comes from top to certain height h or from bottom it rises to certain height h. H will remain same. R into or L into 1 minus cos theta. Yes, done.
Yes, sir.
Next sum 53. A body of mass m thrown vertically upwards. Body of mass m thrown vertically upwards. Attains a maximum height h. Reaches maximum height h. At what height kinetic energy? At what height kinetic energy will be 75% of initial value. At what height kinetic energy will be 75% of initial value? Hello?
Yes, sir.
What is constant in case of energy? Total energy is always constant. So kinetic energy at what height will be 75% of initial value? Hello?
Yes, sir.
What is initial value of kinetic energy? Kinetic energy is 75% of initial energy. That means 25% of initial is potential or not? Is potential at that height, correct? Na?
Yes, yes, sir.
Yes, sir.
So potential energy formula, 25% of initial is potential energy. So it is mg dash at that height which we want to calculate. 25% of initial means 25 of mgh, because full kinetic will become full potential at the top. So kinetic energy, I can also write mgh total. This is very important to be understood.
Yes.
See, kinetic energy at highest point will become total potential energy. So I can say total kinetic energy is total potential, which is mgh. 25% means 25 upon 100. mg cancel हो गया. H dash is h by 4 is answer. h by 4. एक मिनट, सबको समझा? प्रतीक, संस्कार.
Yes, sir.
The 25% of initial becomes potential. So 25% of initial kinetic is total potential, which I wrote mgh, and height h dash पे mgh dash. mg cancel both side. H dash is 25 upon 100 h, which is h by 4. Clear? See, पहले ये दिमाग में आ रहा है क्या? Initial kinetic is total potential at the top. ये सबको क्लिक हुआ क्या? जरा हाँ या ना बोलो. Initial kinetic is total potential at top.
Yes, sir.
So can I say
Yes,
total
sir.
kinetic is mgh only?
Yes.
अगर वो समझ गया
Yes.
तो फिर सिंपल है. Then do it. Okay, can I clear this part?
Yes, sir. Yes, sir.
54. A particle is released from height h. A particle is released from height h. At certain height, its kinetic energy is 2 times potential energy. Kinetic energy at certain height is 2 times potential energy at that height. Height and speed at that instant we want. Height and speed at that instant we want to calculate. If I know kinetic energy, I can get speed v. So at certain height, kinetic energy is twice the potential energy at that height. Body is released from height h. A particle is released from height h at certain height. Kinetic energy is 2 times potential energy. So I can say at that height, kinetic energy at height plus potential energy at height is total energy at top, because total energy will remain constant. Kinetic energy at that height is twice potential energy at that height plus potential energy at that height plus total energy at top, which is mg capital H. So 2 times mgh plus mgh is mgh. That means 3 times small h is capital H. So h is h by 3. First part, any doubt, difficulty?
So
Just
No,
copy.
sir.
Just
Sir,
copy.
I did.
Ah,
How did that K become 2P?
hmm. K
Prince,
becomes,
no,
there,
but how is that practically possible? Because K and P at any height will.
no, it is PE at that height. I will make it clear. Suppose here PE is 300, okay? At some point KE becomes 100, then PE is 200 at that point.
Okay, sir.
So,
Understood.
acha, theek hai. You might have confused with the top.
Yeah.
At any height they are telling, the kinetic becomes twice of potential at that.
done, sir.
Sorry, velocity was pending, na? So at h by 3 from the ground, we want what is velocity when body comes down. What is formula for velocity? Root 2 gh, correct? Na? When body is dropped. Hello?
Yes, sir.
And h we got h by 3. Okay, yeah. A option. Sorry, 2gh by 3. A option. 55. A uniform chain has mass m, length L, is placed on frictionless table with length L0 hanging over edge. with L0 hanging over H. So this length on the table is L minus L. The chain begins to slide down. What will be the speed with which the end slides down from the edge? When end is sliding down, so total length L is vertical. Then what is the speed here? We have to calculate. Total mass is M. So wherever is center of mass is hanging one, and center of mass when all comes down, obviously this is L0 by 2 and this is capital L by 2. Then difference in this potential energy will become kinetic energy. हेलो इधर रेस्ट था फिर मोशन पे आ गया ना so loss in potential will become gain in kinetic.
Yes, sir.
So can I say potential energy in first case is mass per unit length which is hanging into length L0. ये मास हो गया ना फर्स्ट वाले का मास पर यूनिट लेंथ मतलब एक का मास तो L0 का मास इज इनटू L0. हेलो हेलो
into
Yes,
GB
sir.
होगा ना?
Yes, sir. Yes.
नहीं अभी तक तो खाली मैंने मास लिखा अभी तो आगे G भी आएगा एंड ये हाइट भी आएगा ना L0 by 2 है ना सो mgh करेक्ट. सेकेंड का पोटेंशियल एनर्जी इज टोटल मास पर यूनिट लेंथ into length L into G into L0 by 2. I hope you followed now. Hello.
Yes, sir.
Yes, sir.
So
P
now
PE2 में L by 2 आएगा ना?
total length L है ना हाँ ये L by 2 है. L by 2. Now loss in potential. Okay, just copy this much then Andrew. L0 का मास है टोटल मास अपॉन टोटल लेंथ एक हो गया इंटू L0. throughout this 2 we can cancel. So G by L, L square minus L naught square equal to V square. Therefore, V is root of G by L, L square minus L naught square. So option C. Completed? Yes, completed. Can I clear now?
Yes, sir.
Sum number 56. If a body of mass 20 gram falls from height 200 meter, body of mass 200 gram, which is 2 into 10 raised to minus 1 kg, falls from the height of 200 meter, and its total potential is converted into kinetic at the point of contact with the surface. Then decrease in potential energy at the point of contact is how much? Okay. Its total potential energy is converted into kinetic at the point of contact with the surface. Then decrease in potential is how much? Can you tell what will be velocity at the bottom when body falls from 200 meter? Hello? Hello?
Yes, sir.
Entire potential gets converted into kinetic. So decrease in potential will be same as mgh, na?
Yes, sir.
ऊपर से नीचे हो गया वो decrease in potential is mgh. M is 2 into 10 raised to minus 1 into G is 200. G is 9 point. G कितना
So
दे?
it's given 10.
10. So 10 into 10 raised to minus 1 cancel. 400 joule will be potential, loss in potential or decrease in potential at the bottom. 400 joule. So it falls from here, comes to this point. So net loss is mgh. So whatever is loss, that is nothing but potential left out over here. Going to 57.
5 meters, 57.
5 meter. Others what they got? Is the answer same 5 meter? Then everybody try. See whether you are getting 5 meter. Stone of mass 2 kg is projected upward with kinetic energy of 98 joule. The height at which kinetic energy becomes half of original. So that height is half of original means 49. M is 2, G is 9.8 into H becomes 49. Now H is 49 upon 2 into 9.8. That is 490 upon 2 into 98. 49 into 10, 49 into 2. 2.5. Hello? It is 2.5. Huh?
Yes, sir.
Next 58. The system shown in the figure is released from rest. Sum number 58. The system shown in the figure is released from rest. At instant mass m has fallen through height h. The velocity of small m will be how much? This has fallen by height h. Then velocity of this will be how much? This entire system is moving with velocity. So half m plus m into velocity square. Now this is falling down and this is moving up. Net potential energy ka loss will be mgh. Capital M is coming down, so mgh. This is going up, so minus of that plus will be minus small m into gh. This is change in potential energy, this is change in kinetic of entire system. ये m नीचे आया और ये small m ऊपर गया. So going up is plus, coming down if I take minus. So net difference will be m. If you take this downward as plus, this is minus. So net change is m minus mgh equal to half m plus mv square. Both system is moving with same velocity. So net kinetic energy is half into total mass into velocity square. So we can, no, nothing we can cancel. Twice of m minus mgh upon capital M plus small m in root equals to, hello? This one followed what we did?
Yes, sir.
Okay. $59. If v is the instantaneous velocity of body drop from the top of tower, When it is located at height h, which of the following statement remains constant? If v is the velocity of the body drop from height, v is the instantaneous velocity when it is dropped from height. Tower, when it is located at h, then velocity is v. Which of the following is constant? Total energy is always constant. So I can say mgh at that height plus mv square at that height will be always constant. So gh plus v square upon 2 is constant upon m. So gh plus v square by 2 constant upon m is constant. gh plus v square by 2, option B. Next one, 68th. A 2 kg block is dropped from the height of 40 centimeters onto a spring of force constant by maximum distance of the spring being compressed. So earlier, suppose this is the spring, then it get compressed like this. That would be x. K is 1960 Newton. This is same concept wala. M G h plus x should be half k x square. M is 2, G 9.8, height is 40, so 0.4 plus x equals to half into 1960 into x square. This is 980, so we get 0.4 plus x equals to 980 x square upon 2 into 9.8. 9.8 into 100. So again same 0.4 plus x equals to 50x square. So this is 50 x square minus x minus 0.5 equal to 0. Same thing is repeated again. First case diagram was not given. This case diagram is given. Can you tell answer now in meter?
0.1.
0.1 meter. Same we got. All of you have followed the same sum. It is repeated. Only first wala diagram was not given. This time they have given diagram. Once you complete, tell. Then I am doing next sum. I think you all have completed this one.
Yes, sir.
61, last sum today we are doing. Till 62 I am doing. A pendulum of length 2 meter, pendulum of length 2 meter is left at A. When it reaches to B, 10% of total energy due to air resistance is lost. Then velocity at B is how much? 10% lost. So what is left out? 90% is left, that means.
Yes, sir.
So can I say 90% of this potential energy, when it is here, that means it is at height h above, which is nothing but length of the string. So 90% of mg into length of string will become kinetic energy half mv square at the bottom. So 90 into 10, length is 9.8 ले लेता हूँ. Length is 2 equals to half v square. Length is 2 meter, 90%, 10% of it, when it reaches B, it loses 10% of total energy, then velocity at B is. Velocity at V will be root of 90. If you take 10 into 10 into 4, 90% is 90 upon 100. So this will be 90 upon 100. 1, 2, 1, 2, 0 cancel. V equals to 3, 4 ka square root 2, 6 meter per second. 6 meter per second. Loss in potential is gain in kinetic, but only 90% of potential is converted into kinetic. 10 is lost due to friction. 90% is left. Net work done by kinetic friction. Any friction can be sometimes positive, sometimes negative. So C is the answer. So done.
Yes, sir.
That's all for today.